Hello and welcome. One of the topics that isn't really covered in our book is how to graph rational functions. So this video will help you get some idea of how we do that work. And there are also several supplements that deal with how you graph rational functions. And you should probably begin by reading the one entitled Graphing Rational Functions. They're all on your assignment sheet. So I'm going to kind of go through some of these ideas probably a little bit quickly, and when you read the supplement, hopefully it'll make a little bit more sense. So off we go. So when we're graphing rational functions, there are really four big things. We want to make sure that we sketch the y-intercept, the x-intercepts, which are really the roots, the vertical asymptotes, and the horizontal asymptote. So let's spend some time on this. To get the y-intercept, we just set x equal to 0, because that's when the y-intercept happens, when x is 0. To get the x-intercept, we set the top equal to 0, because we'll have an x-intercept, in other words a root or a 0, when the top is 0. What's next? To get the vertical asymptote, we set the bottom equal to 0. When you set the bottom equal to 0, then the whole expression blows up, and that's when we get a vertical asymptote. And finally, to get a horizontal asymptote, now that's covered in a lot of detail on the handout. But basically, we look at the degree of the top and bottom, and we kind of figure out how they work. So let's just add in here. Okay, the y-intercept. The y-intercept is what you get when you set x equal to 0. So the y-intercept is going to be minus a half. The x-intercept is what you get when you set the top equal to 0. So that's x is equal to 2. The vertical asymptote, set the bottom equal to 0, and that's going to be x is equal to minus 4. And finally, the horizontal asymptote, well, I'll just mention this. If the degree of the top and the bottom is the same, then the horizontal asymptote, which also talks about end behavior, is simply the quotient of the coefficients before the x. So let me just mention this. The horizontal asymptote is really all about end behavior, what happens only at the ends. And so in this case, y equals 1 is going to be the horizontal asymptote. So once we take care of all that information, we're ready to graph it. So what I've done here is I've just put down all the things that we learned. The y-intercept, the x-intercept, the horizontal asymptote, and the vertical asymptote. And now when I graph it, I find it's best to start at the y-intercept and then look to the right. I have a root, and then I have an asymptote. And here I am here, and I have an asymptote, which should have kept going down. And then I have over here an asymptote and another asymptote. And that's the graph of y equals x minus 2 over x plus 4. All right, we'll do a few more. All right, so this looks a lot more complicated. And what we want to do is answer these four pieces of information. So for the y-intercept, I set x equal to 0. And if I do that, I get minus 3 times 4 over minus 5 times 16. And so I believe you get 3 over 20. The x-intercept is what makes the top 0. So that's going to be 3 and minus 2. And minus 2 is special because of that squared. The vertical asymptotes are what makes the bottom equal to 0. And so we get x equals 5 and x equals minus 4. And that minus 4 is special because, again, of this squared. We'll see what that does. Finally, the horizontal asymptote. If we were to multiply the top out, the leading term would be 1x cubed. On the bottom, 1x cubed. And so the horizontal asymptote is just y equals 1. So now we'll try to put all this information together and see what it looks like. Okay, so let's see how we can do here. The y-intercept is 3/20, so that's something up there. There is a x-intercept at 3 and one at minus 2. And the minus 2 is special. Because this is squared, it behaves like y equals x squared. In other words, it's either going to look like that or it's going to look like that. We don't know quite which one yet. We have a vertical asymptote at x equals minus 4 and the vertical asymptote at x equals 5. And remember, the one at minus 4 was special, and it's special because that's squared. What that means is it does the same thing on both sides. It either goes up on both sides or down on both sides, and we'll figure out which one in a second. So here we go. We start at the y-intercept, and we look to the right, and there's a root. And we go through, and there's an asymptote. And we get close to it. Then we go on the other side of the asymptote and get close to the horizontal asymptote. Now here's where it gets a little bit more interesting. Start back at the y-intercept and look to the left. And this is what I like to call a bouncy root. And I go up, and these arrows here are reminding me I do the same thing on each side. So I'm going up there, and then I get close to that horizontal asymptote. And there's my graph. Ta-da! Okay, so check this one out. One of the things to notice, and it's really important to notice, is that we have the same term on the top and the bottom, which means if x were equal to 2, we would have a 0 in the top and a 0 in the bottom. And what that means is that we have a whole when x is equal to 2. The function is just undefined when x is 2. Okay, so now let's keep track of the other 4 things that we have to keep in mind. But maybe right now what we'll do is we'll just cross out these x minus 2's, keeping in mind that we have a hole there, and we'll deal with that at the very end. Okay, so let's answer the questions. The y-intercept is what we get when we let x equal 0. Well, if we let x equal 0, we get a 5 here and a 16 here. So the y-intercept is 5/16. X-intercept, let the top be 0, and we get minus 5/3. Vertical asymptote, x is equal to 4, and remember that's being squared, so that's a special one. And the horizontal asymptote, a little bit different here. The degree of the top is 1, the degree of the bottom is 2, and so we say that that's bottom heavy, and whenever we're bottom heavy, the horizontal asymptote will be y equals 0, or the x-axis. And so you might want to ask the question now, what happens if we are top heavy, and if the degree of the top happens to be more than the bottom, then there's no horizontal asymptote, and the graph blows up at the ends. And all of this is covered probably in a little bit more textual detail in the supplement called Graphing Rational Functions. So now let's put this all together on a graph and see what we get. Okay, so here we go. We have a y-intercept at 5/16, somewhere up here. Don't have to be too fussy. The really important thing is a y-intercept positive or negative. We have an x-intercept at minus 5/3. That's between minus 1 and minus 2. We have a vertical asymptote at x equals 4, and remember that's a special one, so it either goes up on both sides or down on both sides. And the horizontal asymptote is y equals 0. And Oh, and there's a hole at 2, so we got to remember that. So here we go. We start at the y-intercept, and we look to the right, and we can't go down. That's a big important thing. If we went down, that would mean a root, and we know that this is the only root. So therefore, we have to go up, and if we look here, we got a little cheat thing. That means we go up on the other side, and then we come down. And right here, I start again at my y-intercept, and I look to the left. I go through that root, but now I got to get close here. And the one thing I got to remember now is that we have a hole at 2. So I go back to 2, and I make that be an open hole. And there you go. So that's a lot of information on graphing rational functions. It's a pretty cool topic. And you'll have a couple of supplements to practice with that on your assignment sheet. All right, see you next time.